For now, I will present the Assistant Professor of Multimedia Science Department, Dr. Karim Hajjar. Please.
السلام عليكم. بسم الله الرحمن الرحيم. والصلاة والسلام على أشرف المرسلين. So it is my pleasure to present my research paper that has been published. And this research paper, I did it with Dr. Ahmed Jadidi. The title of my presentation is A New Approach for Scheduling Tasks and or Jobs in Big Data Cluster. This is my agenda for the talk. So I'll start with the introduction. So I'll brief you about the topic of my research. Then I will start talking about what is big data, just in few words. Then I will talk about the 4 V's that has been defined by IBM for defining the different categories of the V's. Then I will talk about the Apache Hadoop, the Hadoop ecosystem, the role of the scheduler in the big data. Then I'll talk about the different type of classification of the Hadoop schedulers. Then I will define our approach to optimize and improve the scheduler in big data clusters. Then finally, I will just give you a brief about the experiment results that we have obtained, finally, and the conclusion. Okay, so if I will ask you what is big data, so what you can answer to me? Okay, I just want from the audience, okay, some... Sorry? Yeah, it can be. Yes. Yeah. So by the way, we have a lot of definitions of big data, and I have selected one of them, which is extremely large data sets that may be analyzed computationally to reveal patterns, trends, and association, especially relating to human behavior and interaction. So why we are talking about big data nowadays? Because the data, most of the data that we have nowadays are generated by users, okay, which is not the case maybe 10 years or 15 years ago. So we are producing data, and we are producing a lot of data. And you have to think about why most of the apps that we have nowadays into our mobile phones are free. Why? Because they are getting money from our data. Okay, so that's the reason why. So they are using our data just to generate revenues. Okay, so they will produce certain kind of profile about you. Okay, and they will sell it to marketing companies, and these companies will provide the ads into their pages, and you can guess the things later that are how much money are generated from your data. Fine. So I will talk about the 4 V's that has been defined by IBM. So the first V is the volume, that is the scale of data. Of course, we have a lot of data that is generated every day, okay, and you need to know that a big number of hours, okay, are uploaded every day in YouTube, okay, so it's more than what you think about. It's maybe 100 hours, okay, roughly uploaded every day in YouTube. Of course, this data, of course, or these videos needs to be processed. So the first V is the volume. The second one is the velocity, because you need to treat this data. So how you are going to treat it, and which computer can fit all of this data when we are now talking about the peta data, okay, which is more than you imagine. Okay, so this is one thing that we need to consider. So also we have the variety. So not all the data that we have nowadays is structured. Okay, it has been estimated that 80% of all the data exchanged worldwide is unstructured. So if it is unstructured, so you need to find a way, okay, how to analyze this data. So it's coming into different formats, different structures, and you cannot create an algorithm that will treat all of this data. The last one is the veracity, which is the uncertainty of data, of course. So the data has some noise that you need to consider. Sometimes some of the data is missing, so what you need to do in that case. So this is the last four of these as it has been defined by IBM. Okay, so one of the things that make the big data treated nowadays is because the open source community has created the Apache Hadoop. So the Apache Hadoop is a project, okay, that is coming in open source that allows to treat, okay, the big data in a framework, okay. And I just want to highlight that this project, okay, is nowadays is still going on and is still improving, and all the companies that they are using big data at the base, they are using the Hadoop framework. Fine. One of the, let's say, distributions of Hadoop, okay, we'll find two distributions. One of them is named Cloudera, okay, and this one is, of course, using the Apache Hadoop ecosystem. And we have another one that is Hortonworks. So these two are open source and they provide a framework, okay, for using the big data. So what do we have? We have different layers, okay, as you see. And of course, the upper level layer, as you see, we have different components. So one of them is for batch processing. We have also for analytic SQL. We have for the search engine. We have machine learning. We're using different technologies such as Spark, MapReduce, Mahout, and we have also the stream processing, Sparks, and different other third-party application. So the main problems that we are facing into big data clusters is once you have a job that you need to assign to the cluster. Of course, we are talking about clusters that are having big numbers of computers. So how you assign these tasks, okay? So you want to assign it in a way that you can optimize, okay, the results, because you want sometimes the data to be treated in a real time, and you have a flow of data that is coming as a streaming. So if you are having a bad scheduler, of course, the performance of the big data will fail, or at least will give bad results. So the research community has tried to cover this topic, so for research topic, and we have different categories of job schedulers. Okay, we have the first category that is the static scheduler. So this one is from its name, it's static, so it's just defining, okay, the list of job schedulers that is coming. It is put it in for example, FIFO scheduler, okay? So first in, first out, and it will assign the task and it will run. But the main problem of this type of scheduler is that knowing the status of every computer in the cluster. So it might assign the task to a computer that is already busy, okay? So what happens in that time? Of course, it will be put in the FIFO, and it will lead, of course, to wait. So you cannot obtain real-time performance and appropriate results. The second category is the improved static schedulers. Of course, they have tried to improve these static schedulers. Okay, we have the LATE and the SAMR, which is self-adaptive MapReduce. But the latest trend that we have, and most of the researchers are nowadays focusing on the dynamic scheduler. So dynamic scheduler, it means that you need to know the status of your clusters before assigning the task. And we have two main research that are coming. It's deadline-aware scheduler and the energy-aware scheduler. Of course, the idea is to assign the scheduler according to the status of the cluster. So we decided to go further in the type of dynamic scheduler. So we want to know okay, what is the current status, okay, of the cluster in terms of different, let's say, features. We want to know what is the CPU load of every computer in the cluster. We want to know also what is the quantity of RAM in the load, so we would like to see it, the input-output load, and also the network load. So moreover, we have focused also on the type of the job. So sometimes the type of the job will decide for you, okay? So if you would like to have, for example, a real-time job, or this job, the process might take time, so you want to say, okay, I will delay it later on. So, and we have categorized the different type of job regarding as I said before, the upper layer that I have described before in the Cloudera big data distribution. So we have to know what is the type of job. Is it a Spark for we want to have it, okay, the load, this job will be, let's say, executed mainly in the RAM, okay? The opposite, for example, HBase, it is going to be a database that will use extensively the hard disk, so input-output, and we have other things. So the research that we did, we came up with this formula, so we would like to know the resource load, okay? So we'll have to know what is the load of the CPU, the load of the RAM, the load of the input-output, and the net. And we want to know also from the history, okay, of every computer in the cluster. So we would like to have that. Fine. So then we came up with this algorithm, and we, thanks to research that I will talk about later on, okay, we came up with these values, okay, according to the job and the type of the job. So for example, if Apache Spark is being used, okay, so we'll have these values in case that it is HBase MapReduce, and of course, we'll compute that in this pseudocode that it's in front of you. Then finally, we'll assign the task to the job. Fine, so so all the values that I have shown you, okay, is deducted from statistics that we have conducted on word count and grep. These are two, let's say, programs that are used for benchmarking, okay, the big data, let's say, distribution. Okay, so by varying the input of text of files using different sizes, such as 2.9 gigabyte, 1.7, and 786.4 megabyte in two different distribution, that is Cloudera and Hortonworks, which are the most well-known big data distribution nowadays. Okay, so the experimental results that we have, so we tested and validated our proposed system to use 4 machines. Okay, these are mainly the specification of these machines. Okay, so it's a cluster that has 16 GB of RAM. Okay, Core i7, okay, and 100 megabyte the network connection. And we have used it, okay, CentOS, that is the distribution, okay, of the Linux, and on the top of it we have the Cloudera, plus the Java Development Kit 1.8, and the environment of Hadoop was 1.2.1. Finally, these are the cluster, how it is configured. So we need to have a node A that we have named the name node. It means I just want to highlight one point, is that the name node is considered as the server in the big data, and the clients are named data nodes. So we have 3 data nodes. So as you see, this cluster is homogeneous, so they are having the same configuration. Okay, so the experiment results that we did, of course, so we would like also to use the word count and the grep, okay, for the task of the scheduling. And we have obtained these results. So we compared our task scheduler with the FIFO scheduler, the capacity scheduler, and on different sizes of the data size, so which is, as I said before, 786, 1.7, and 2.9. And we see that our task scheduler is improving, okay, the CPU time. Finally, okay, so we have presented a new approach for scheduling tasks in big data clusters. Okay, so our algorithm is, let's say, given better results, okay, than the one that I have cited before. And our idea is to make sure that we conduct this research by seeing how this improved scheduler, okay, will work on heterogeneous clusters, so by modifying the different computer, and see what the results can be obtained. Thank you all for your kind attention. And if you have some questions.